forces are of two types. One is the contact force and other one is the non-contact force. Now, normal reaction and the force of friction. If a force is applied on the body moves in the direction of the applied force. But two forces act on the body. If the body is placed on a horizontal plane, the force mg, which is act vertical downward directions, and the normal reaction, which act opposite to the direction of the weight of the body. That's normal reaction is equal to the weight of the body. If a force is applied on the body which is placed on an horizontal plane, then weight of the mg acting vertically downwards and the normal reaction balance the weight of the body in upward directions, and if the body moves, then a force of friction is worked against the motion. That force is called friction force, and the contact force is the resultant of the normal of reaction and force of friction. And the parallel component is that if the body is applied on the body, if a force is applied on the body and the body moves along the direction of the force in horizontal direction, then a force of friction comes into play at the place of contact tangentially to the surface in opposite direction of the motion. That is called the parallel component of the. In this case, the friction force is the parallel component of the external force applied on the body. So now there are some pictures here, so you can draw the normal reaction for the following cases. Always normal of reaction is parallel to the surface, perpendicular to the surface where the body is placed. If a body is in horizontal plane, then the normal reaction act up in upward direction, along upward direction in perpendicular upward direction on the horizontal body. If a body is placed on an inclined plane, then it is perpendicular upwards on the inclined plane. Now another force is a tension. Tension is the resistance of a string or a rope against any change in its original composition is called tensile force or tension. Tension always acts away from the tied ends, and tension is always pulling in nature. जैसे ये डायग्राम में आप फिगर में आप देख रहे हैं कि बॉय इज pulling a rope which one end is tied with a wall. Then a tension developed by the boy towards the direction of the wall, and the wall developed a tension towards the boy. तो इसका मतलब क्या हो गया? टेंशन ऑलवेज पुलिंग इन नेचर, टेंशन ऑलवेज एक्ट अवे फ्रॉम द टाइड एंड्स, और ये रेजिस्टेंस फोर्स है जो कि स्ट्रिंग या रोप पे लगता है. इसका भी ऐसा यूनिट जो है वो न्यूटन होता है. अब कॉन्टैक्ट फोर्स है, नॉन कॉन्टैक्ट फोर्स के बारे में हमने पढ़ लिया. अब नॉन कॉन्टैक्ट फोर्स के बारे में आते हैं. अ नॉन कॉन्टैक्ट फोर्स इज अ फोर्स विच एक्ट ऑन एन ऑब्जेक्ट विदाउट कमिंग फिजिकली इन कॉन्टैक्ट विद इट. एग्जाम्पल ग्रेविटेशनल फोर्स, example magnetic force. These are the non-contact forces. अब now next force is the weight. The weight of an object of mass m near the surface of the earth is equal to mg, where g is the acceleration due to gravity and its value is 9.8 meter per second square. It is always directed towards center of the earth. Look in this numerical. A block of mass 2 kg on a frictionless plane inclined at an angle 60 degree. Theta is 60 degree and mass is 2 kg, with the horizontal is supported using a string attached to the body and held it and angle 60 degree to the plane. So calculate the tension in the string if the block is stationary. And here G value of G is given, that is 10 meter per second square. As the block is stationary, that means net force on the body is equal to 0. तो अगर इसके mg के हम कंपोनेंट्स बनाएंगे, एक mg का कंपोनेंट जो होगा वो होगा mg cos थीटा, वो परपेंडिकुलर टू द हॉरिजॉन्टल प्लेन, एंड mg sin थीटा that is down the inclined plane, and force of friction act opposite to the mg sin theta. So then the tension mg sin 60 is equal to T cos 60. T is the tension, because we are using a string attached to the body. तो वेट के जो कंपोनेंट जो है mg sin 60 डिग्री, वो इक्वल टू हो जाएगा, उसके ऑपोजिंग फोर्स जो है वो है T cos 60. तो sin 60 अपॉन cos 60 एंड T इज इक्वल टू हो गया mg sin 60 अपॉन cos 60. sin 60 हो गया √3/2 एंड cos 60 हो गया 1/2. So therefore T is equal to mg √3, m given 2 kg and G is the 10. So therefore tension is equal to 20 √3 Newton.